Nordson Electronic Solutions. Everything you need for precision automated fluid dispensing, conformal coating, plasma surface treatment, and selective soldering. Our passion is helping customers take their processes further, faster, with best-in-class technologies, dedicated global sales and support teams, and unmatched applications expertise. From the names you respect, Asamtec Fluid Dispensing and Conformal Coating, March Plasma Treatment, and Select for selective soldering, we offer years of experience in advanced technology solutions for electronics manufacturing. Take your electronics assembly process further, faster.
Hi, this is Keith Bryant for Global SMT and Packaging at Apex 2022, and I'm here with Chris from Indium, and we're going to talk low temperature and high reliability solder pastes. So, sir, I guess I say over to you and tell us about it.
Sure. Thanks for having us here. The big ticket items that we're promoting at the show and what the industry is all talking about nowadays is low temperature and high reliability, and the combination of both, right? So Durafuse LT really fits into that nice mix with low temperature in mind as well as high reliability, mostly on a drop shock performance standpoint. So when you're comparing the Durafuse LT to the SAC 305, we can actually get higher reliability drop shock performance than the SAC 305 with the Durafuse LT. And that's a really unique and really a really big advancement for the industry. Because up till now we've just had bismuth alloys, and bismuth by nature is very, very brittle. So it is really a great technological advancement from a material science standpoint. At Indium Corporation, we really believe that material science changes the world, and that's what we strive for.
Okay, so how low is low in terms of temperature?
Sure, so the Durafuse LT, we like to say the reflow temperatures are between 200 and 210 degrees C. We are working on further development to bring that temperature down even further to 190, 180, 160, so on and so forth. There's a lot of interest in ultra low temperature on the market as well for wearable applications and other step soldering type applications. So it's important that we keep striving to go further down the line in temperature.
Yeah. So at the bottom, I guess you're looking at low cost materials in flexibles and this kind of stuff that you need to solder.
Absolutely, yeah. Absolutely. So and again, a lot of the wearable devices really need that drop shock reliability, and that's where Durafuse LT comes in. There still are a number of applications like servers, TVs that don't care about drop shock performance, right? So they can use the bismuth type alloys. However, they're more interested in better thermal cycling reliability than drop shock reliability. So we have the Bismuth Plus alloy coming out that is right up their alley. It's a higher thermal cycling performance material, but still incorporates the bismuth in the alloy.
Yeah, servers have been a big issue because of the size of the boards, the cost, the thickness of the boards to get soldered, and you know it's really been a challenge with the bismuth stuff. Yeah. So you know it'd be good to have something that's going to perform a lot better for them.
No, absolutely. Yeah. And then, you know, we're taking our Durafuse technology to a whole nother realm as well, where high reliability alloys are important for higher thermal cycling performance in the automotive realm, in the server realm, and we're coming out with a Durafuse HR as well, high reliability for HR. So one of the challenges with high reliability alloys has been voiding. And with our new Durafuse technology that we're developing, we're going to reduce voiding with that technology as well as improve the thermal cycling performance of the alloy.
Yeah, I guess when you're talking about IGBTs and things, you really need the thermal performance because the components are going to be up through a heat sink, and what's moving let's say what's hopefully moving the heat from A to B is your solder, and if you've got 25% voiding, you've got 25% less heat you can shift, and then you've got dies cracking and all sorts of stuff, which is generally, unfortunately, what the industry is seeing in a lot of cases at the moment, and it's one of the big failure mechanisms that people are worrying about with not only electric vehicles but wind farms and all of this kind of stuff. So yeah, if you can have something that's reliable and reducing voiding, then you're ticking a lot of the boxes.
Yeah, absolutely. And I think the other reliability thing that especially the EV market is interested in is SIR and ECM performance. The flux reliability, not just the alloy reliability.
Yeah.
You know, the 8.9 HF is a fantastic product for high reliability flux applications where it meets what we like to call enhanced SIR performance, going above and beyond the IPC J standard for BSIR, you know, longer times. So we're going from 168 hours to 1,000 hours, tighter spaced lines, and higher voltages in some cases. So each automotive company has kind of their own SIR and ECM testing standards that they want to meet. They're becoming more stringent, and the 8.9 HF seems to or does meet all of those enhanced type testing requirements.
Yeah, it's scary for our industry because we're used to relatively low voltages on our boards, and then you go to electric vehicles, and that's gone straight out the window.
Absolutely.
And you know, we're seeing a lot of worry about conductive filaments, about a whole load of stuff, and you know, people are washing their boards, in some cases double washing and drying their boards, then then maybe plasma treating them, then conformally coating them, and you're adding a huge amount of extra cost into that board.
Yeah.
And if you can come up with a flux that works and does its job and then becomes inert afterwards, then yeah, you're coming up with a huge number of advantages.
Yeah, and you really have to take into account all of the defects that are possible out there in the industry as well. So whether it's head and pillow performance or non-wet open performance from a warpage standpoint, or maybe it's just that the solder joints are cracking. You might have dendritic growth concerns, so that's where the SIR and ECM comes into play. So you know, we're looking at the industry's problems, and we're trying to solve those problems with material science advancements. So it's really a unique time within the industry, I think, where there's all these new developments and new technologies that we're trying to build. And each of them are bringing new challenges to the table. So it offers the opportunity for some of these new technologies to come into play and really solve the problems of the industry.
Yeah, it's one of those things. It doesn't really matter where you're sitting in our industry now. Material suppliers probably more than others, but you're no longer a supplier, you're a solution provider, and the problems in a lot of cases are still very new. And you know, when you fix something, when you bring the temperature down, and then you had brittleness, and that didn't work, and now you have to try and do other stuff to still stay where you are. And yeah, your R&D team must be pretty much tearing their hair out from month to month as something new pops up to hit them.
Well, that's the exciting part about this industry is technology is always advancing, it's always changing, and there's always new challenges to solve. You know, I always said I'd rather be busy than bored. Well, there's certainly plenty of opportunity within this industry to be busy.
Yeah, and the speed of things, you know, we talk about Moore's law for the semiconductors. We don't really have a parallel for surface mount assembly, but if we had one, you know, it's like moved up 4 gears in the last 2-3 years.
Oh, for sure. For sure.
Yeah, and that puts, you know, an exponential strain on guys like yourselves to come up with the really good solutions for things that are there. You know, I can remember it wasn't that long ago when people were saying, well, you know, you either have to live with all the damage you're going to do with a really high temperature reflow, or you're going to have to live with brittle joints. And, you know, all the people were coming back at seminars and presentations that I attended and saying, well, you know, we can't have A and we can't have B, but, you know, we need something else. And, you know, it's got to put a lot of pressure on all of you guys out there to develop stuff. And it's good that you're coming up with so many solutions.
Yeah, lots of new solutions from Indium Corporation on lots of different fronts, whether it's the mobile industry with miniaturization, the infrastructure industry with 5G implementation, the automotive with EV. There's so many new challenges out there that we're developing products for, that we already have products for, and didn't maybe know about it at first. A lot of our products, oftentimes they meet the needs of the future requirements, and we don't know until we get there, though. That's another exciting part of experimentation and product development.
Yeah, and I have to say it's good. Indium has always been known for its strong R&D and great new products, and it's good that you've come in and shared with us to show that, I won't say things are staying the same, but they're actually moving faster than they were before, and probably if we were to come and sit here in another year, they'd be moving even faster.
Absolutely.
So thank you for coming in and sharing with us.
Thank you very much, Keith.